All right, so we are on our last journal for this section here. And so we're going to be looking at a bell work problem that is actually something you're going to see on the chapter test that we'll have next Wednesday, September the 4th. So I brought this problem just so that we can practice some of these old skills again. You might recognize this inequality. It's in set notation, and we have to sketch the graph and write the interval notation. So let's go ahead and first sketch that graph. So if we're going to sketch a graph, we need a number line, right? And we learned before that if we have inequality signs with those lines underneath it, it means that it equals the number. So that means we're going to use a closed circle because it actually can touch that number. And if we have inequalities without the line, that means it cannot equal to that number, but it gets really close but doesn't touch it. So we use an open circle. And for interval notation, that means that a closed circle would use a bracket, and an open circle we use a parentheses. So that's what we learned when we were first introduced with inequalities and interval notations. So on this graph here, I'm going to first go ahead and place my endpoints here. So I have a -3 and a 4, so I got to place those numbers down. I need an open circle on that 3, closed circle on that 4, because that inequality sign doesn't have a line, so it's open. It does have a line, so it's closed. So now I have to figure out, where does this x value lie? So this x value is between -3 and 4. That means I'm shading in the middle part here, so in between -3 and 4. So this shading is going to represent where x is. Okay, and then I am done here. And so now I have to draw the interval notation, or write out at the interval notation, which is basically like, what number does this highlighted region start from? It starts from -3 to 4, so I need those as my numbers. And because 3 is an open circle, I need a parentheses, and 4 is a closed circle, so I need a bracket. And there we have it. That's my interval notation. And so that's all. So for this lesson here, we are going to be talking about something called absolute values. You might have heard of it before, but we're going to go over it again, and we're going to do some practice problems. And this is going to help you out with page 6 of that packet. All right, here. So let's talk about absolute value functions. So absolute value functions are these vertical lines that encapsulated like an expression or a number. So let's just go over some things about absolute value and what they do. So what do absolute values do to negative numbers? Well, if I have like a negative number, let's say -3, well, what happens is it becomes a positive number. So it changes it to a positive number. When I have a positive number, like +3, and it goes in, it's still a 3. So it's still a positive number. And if it's a 0 that goes into an absolute value, well, that's just still going to be 0. 0 is not a negative number or a positive number, but so we just get 0. And I'll explain why they become just positive numbers. And so this here, nothing happens. And actually, if I really think about it here, nothing really happens when you put in a positive number. So maybe I should just put nothing here. Okay, so what do you do? So why do absolute values never give negative values? Well, that's because absolute values measure the distance from 0. Now, I don't know if you can see this picture here. So absolute values measure the distance from 0. So let's say we were at that -3, right? Well, that -3 is 3 units away from 0. So we are actually looking at the distance from that number, and distance is never a negative number, right? So that's why that's a 3. If I were to choose the absolute value of 5, I'm counting how many units that's away from 0. And so that's 5. When we're at 0, the absolute value of 0, well, you don't go left, you don't go right, you're not shifting units. So that's why the distance is 0, because you don't have to go anywhere. You don't have to measure anywhere. And so that's a little bit of background idea with absolute values. But I want the takeaway from this is that when you stick something in an absolute value is that it turned into a positive number, but it really could have been a negative number inside that absolute value, okay? So now let's take a look at some practice problems where we're actually computing stuff. All right, let's take a look at this problem here. So with example 1, I have some stuff inside the absolute value, and it says that the absolute value of 3x equals positive 12. Now here's the thing. If I stick something in, right, and it gave me a positive number, couldn't it have been that this could have been a negative 12, right? So yes, it gives me a positive 12, but how do I know that it wasn't actually a negative 12 that was inside, and then the absolute value changed it to a positive 12, right? So here's the thing. This answer could have been positive, or it could have been a negative 12. So whenever you're computing with an absolute value, you have to split the problem into two problems. So this could have been 3x equals positive 12, or it could have been 3x equals negative 12. And so when you're starting an absolute value problem, in order to get rid of the absolute value signs, you have to split it up into two equations. One positive, one negative, and then you solve for your x. So I'm going to try to solve for this x here by dividing 3. So this is just basic algebra. You got to try to get the x by itself. So if I divide 12 by 3, I get 4. And so that's my first x value. I'll box it. And then this one here, if I divide by 3, this is going to be x equals negative 4. And I have two x values, and it just so happened that these two are like the same numbers but different in signs. That's not always the case, okay? So you do need to fully solve it out. Let's try out this one here again. This could have been a positive 9, or it could have been a negative 9. So we're going to split it up into two equations. That way we can also get rid of the absolute value signs. So this could have been 3x minus 1 equals positive 9, or 3x minus 1 equals negative 9. But then we go ahead and solve it like your typical algebra equation. But here's the thing. Do I move the 1 over first or the 3? So in math, we move over, in this case, the negative 1. We have to add 1 to both sides first before we take care of the 3. The reason why is because whatever you're trying to solve, so we're trying to solve for x, right? Well, the thing that's further away from it, we move over first. Ask yourself this, is the 3 further away from x, or is it the negative 1? The negative 1 is further away, right? The 3 is like literally attached to the x by the hip, if you could imagine that. So the 3 is close to the x, so we want to move away the 1 first by adding that to both sides. So that cancels it. And 3x is now equal to 10 if we add that 1. And then we divide over the 3. And so x is equal to, well, 10 over 3 can't be reduced, so we can just leave that as a fraction. So just 10 over 3. And so the reason why we move the thing that's further away is because in a way we're doing we're undoing order of operation. So it's like we're doing the opposite of what we would think order of operation is. And so generally you want to think of it as like you got to move the thing that's further away from x. So the thing that's further away is the 1, then it's the 3. So we're going to do that same thing here. We're going to add 1 to both sides first. That's going to cancel, so we have 3x equals negative 9 plus 1 is negative 8. Divide that by 3. That cancels, so x is equal to negative 8 over 3. And so we have negative 8 over 3, which can't reduce nicely, so I'll just leave that as it is. All right, now that we've gotten a taste of absolute values here, I'm going to try out these lightsabers. So this tool, I can use lightsabers, by the way. But anyhow, so I can take any absolute value, split it into two functions, one that's positive and the other one that's a negative number. But now we're going to take a look at problems where you have absolute values, but then you have other stuff outside of the absolute values, and we're going to see how we can take care of that. So stay tuned for the next slide. All right, so let's take a look at these problems here. So notice how like this 5 here is outside this absolute value, right? And so what I have to do is I need to take care of this 5. But let me just mention here, the biggest mistake when people are working with absolute values is they treat them like parentheses. Let me just tell you right here is that no, you do not ever treat absolute value signs like you would treat parentheses, okay? That's a big no-no. Never treat them like parentheses where you distribute that 5 inside the absolute values. That there is just a no-no in math, okay? So you never distribute the number outside into the into the absolute values because that's not how absolute values work. What you have to do instead is get rid of anything that's outside the absolute value. So to do that, this 5 is sitting outside the absolute value as if it was like right next to it, right? So what type of operation is this 5 implying? Well, it's implying multiplication. Anything that sits next to like an expression is implying multiplication. So in order to undo multiplication, we have to divide. So we're going to divide that 5 off, and that leaves us with 2x minus 7 equals 3. Now, notice that this absolute value sign is by itself, right? And so from here on out, we can solve it like we did before. So let me just mention here, I'm going to put this in red here. So the first thing you want to do when you're solving for absolute value is to make sure the absolute value is by itself. Then you can split into 2 equations. But before you can do that, you have to make sure the absolute value is by itself. So now that it is, we can split it up into 2. We can say that this is 2x minus 7 equals positive 3. And we can say that this is 2x minus 7 equals negative 3. And then try to solve the problem. So we can add 7 to both sides. Actually, I noticed I don't have a lot of room here. So what I'm going to do is I'm going to erase this problem and then I'll write it back later. Yeah, that's what I'll do. And so going back to this problem here, let's see, pink pen, yeah. So I'm going to add 7 to both sides. That cancels. Let me make that a little thicker, maybe this size. And so now I have 2x equals 7 plus 3 is 10. Divide that by 2. That's going to be x equals 5, right? And so that's my first x value. I'm going to do the same here. I'm going to add 7 to both sides. That cancels. So I have 2x equals negative 3 plus 7 is 4. And so if I divide that by 2, that's going to be x equals 2. Yeah. And so now I have my 2x values here. And so I'm done because I have x by itself. So now let's try out that b, the problem that was part b. Let me shrink this down so I have more room. So part B is an interesting problem. If you had copied it down before, it was negative 5 in front this time. Everything else was the same as part A. So with this problem here, we're going to start with what I said up here in the top. So first, make sure the absolute value is by itself. This negative 5 needs to be pushed over to the other side to make this absolute value by itself. And so that's what we're going to do. We're going to divide that by negative 5 on both sides. So that cancels. So now I have the absolute value of 2x minus 7 equals negative 3. Whoa, hold up here. Let's take a look at what we got. Because I want you to pay attention. Whenever you finally get the absolute value by itself, you should always look at what it equals. Because this here says that the absolute value of this expression equals negative 3. Didn't we learn in the very beginning of the bell work, or, in the definition slide, that whenever you put a negative number inside, it should come out as a positive number, right? All the problems that we've been working with had a positive number on the right-hand side. Look back at your other problems. They did. This one has a negative number, and that can't happen. Absolute values will always spit out a positive number. And so in this case, this shouldn't have happened, right? And so if you notice that you get a negative sign on the opposite side of your absolute value, that means that this is no solution. X could not have produced this value because absolute value never give out, or never, how about this? Let me write it this way. Never equal negative numbers. Okay, so hopefully that clears up a few things. I like to show this problem because, it shows one of those bumps that you can get in a problem. All right, let's take a look at our last slide for the day. Looking at example 3 here, I brought up another problem, just has more stuff on the outside of the absolute value, so that way we get more practice with that. Just like we were solving that problem previously where I asked you, what do you move over first? Is it that 1 or do you move over the 2? So this problem is very similar. Do I move over the 7 first, or do I have to move over the 2? And now we have to look at what is further away from the absolute value sign. So here's my absolute value sign. I have to get this guy by itself. So the 2 is right next to it, right? Whereas the 7 is a little bit further. So I have to detach that 7 first by adding that over. So those same rules apply. So I'm going to bring down now the 3x minus 1 in absolute value equals 5 plus 7 is 12. I have to get rid of that 2 by dividing that off. That cancels, and then I have 3x minus 1 in absolute value is 12 divided by 2 gives me 6. And so now I have the absolute value by itself. So every time you get to this part, you need to look at your other side of the equal sign and make sure it's a positive number. And it is. So now, because it's a positive number, you can split it into 2 equations. So I'm going to go ahead and split this into 2 equations. I'm going to actually write it up here just because I don't have any room down there. So this will be 3x minus 1 equals positive 6, and 3x minus 1 equals negative 6. And then I'll solve that out. Now, if this was a negative 6, that means you could stop right there. Absolute value signs don't give negative numbers, so this is a no solution. So if you get a negative number, actually, it turns out the problems become super easy because all you got to do is write no solution. But if it isn't a negative number, just split it into 2. It's not a hard problem. You just got to solve for x. So if I solve for x, I got to add 1 to both sides. That brings me with 3x equals 7. Divide that 3 off. That is going to be x equals 7 over 3. I can't reduce that, so that's it for this side. If I add 1 to this side, that's 3x equals negative 6 plus 1. That's negative 5. Got to divide that 3 off. So that's going to be x equals negative 5 over 3. And that was my other x value. Okay, so I got both x values. X is by itself. I'm done. Now, I have a special problem for us, so that way you can see how we could deal with x squared. Now, we've been dealing with x to the first power, but I just want to bring this to show just so you guys can see later on how do we handle this, and so that you can get used to the formatting here. But I think here, before we look at the x squared, notice how the absolute value is by itself, right? There's nothing attached outside of it. So, and this side here is a positive number, so I know I can split this up into 2 equations. So I'm going to go ahead and do that, as x squared equals 36 and x squared equals negative 36. Now, I think that when most of us look at this problem here, you guys have this intuitive notion that, a number squared gives you 36. Well, that number has to be 6, right? Because let me do this to the side here. 6 squared is just 6 times 6, which is 36. So x here needed to be 6. But here's the thing. Isn't negative 6 squared, negative 6 times negative 6, also positive 36, right? Yeah, because two negatives multiplied each other will always become a positive number. So that means that negative 6 also works here. Actually, if you guys didn't know this, how you get rid of a square, like this 2 here, is you can take the square root of it, and that actually cancels out the square and the root, but anything you do to one side, remember, you got to do to the other side. And so you guys probably know the square root of 36 is actually 6. But here's the thing that no one probably told you is that when you take a square root, you get the positive and the negative number of it. So every time you take a square root and you know what the positive value is, just also include that negative value of that number. So here's the answer for our first equation. So I have this x value. Now let's take a look at this side here. Now we just talked about this a moment ago. Any number that's squared, think about it. Can you have a negative number? No. Because if you had a negative number that was squared, like these two, you always create a positive number because two negatives times each other will always be a positive number. So in other words, this equation can't happen because any number squared will always result into a positive number. So that means that this is our only solution. Okay, now we are done for today. I want you guys to try out problems now from the packet. So packet 1, page 6. With these notes, you should be able to do some of the problems there. And again, if you guys ever need help, my office hours are usually Monday, Tuesday, Thursdays at lunch. So feel free to jump on in and we can do some math problems together. All right, I hope you guys have a lovely day. See ya.